Does Jupiter's moon, Europa, hide the answer to mankind's oldest question? It is now considered certain that an ocean of gigantic proportions is slumbering beneath the satellite's icy shell, and that it could even be home to life. Although we've known about the existence of the frosty celestial body for over 400 years, its greatest secrets still lie in the shadows. But now, NASA finally wants to shed some light on the galactic darkness. The renowned space agency will be sending a space probe into the realms of Jupiter's moon in a few months' time, and soon after, it will even be diving into its extreme underwater world. Bigger, the mighty Jupiter. No other member of our home system comes close to the overwhelming dimensions of the gigantic gas giant. All in all, the Colossus has a diameter of 143,000 kilometers, and in theory, our Earth would fit inside the planetary king of the solar system no less than 1,300 times. And as befits a planet of this status, Jupiter is by no means alone in its orbits through space. According to our current state of knowledge, it is accompanied by at least 95 moons. The four most impressive so-called Galilean moons are among the largest natural satellites in the solar system. But that's not all. Io, Ganymede, Callisto, and Europa were added to the star charts in 1610 by the astronomer Galileo Galilei, and have always been suspected of carrying revolutionary findings, and possibly even the answer to the oldest question in history. Are we alone in the universe? Given the exuberant diversity of the cosmos, is it even possible that Earth is the only celestial body to have given rise to life? Well, perhaps the solution to the riddle is hidden in a bizarre world that, at first glance, could not be more hostile to life. Because let's be honest, who would expect to find our extraterrestrial neighbors on a moon where the thermometer never climbs above minus 30 degrees Celsius, on a celestial body that is crisscrossed with grotesque craters and furrows, and whose sparse atmosphere hardly deserves its name? And yet, no matter how extreme the initial situation, Jupiter's moon Europa is not just any candidate. It is one of the most promising places when it comes to the question of extraterrestrial life in the solar system. To understand what this is all about, however, we have to turn our gaze away from the several-kilometer-thick water ice shell, and instead immerse ourselves in the breathtaking world hidden behind this frozen mask. The sea under the ice. Frosty on the outside, liquid on the inside. The saltwater ocean hidden beneath Europa's massive crust is probably up to 100 kilometers deep and spans the entire celestial body. In total, this subglacial sea could contain twice as much water as all of Earth's oceans combined. But how did the experts discover this sloshing secret in the first place? Or, to put it another way, how do you detect an ocean that appears invisible at first glance? Well, the first clues of the watery giant were provided by the magnetic field measurements of the Galileo probe, launched toward Jupiter in October 1989. The NASA spacecraft gathered a series of revolutionary findings about the gas giant and its constant companions. These included, in particular, the detection of liquid salt water beneath the surface of Europa. But the satellites Ganymede and Callisto also joined the list of extraterrestrial ocean carriers. In detail, the magnetic field measurements around Europa identified some telltale disturbances in Jupiter's magnetic field. Disturbances that are normally caused by the movements of a conductive liquid. However, since Europa has no rocky crust and is completely covered by ice, a huge magma accumulation seemed unlikely, to say the least, as this would probably have melted the frozen surface long ago. The situation was somewhat different in the case of a subglacial ocean of liquid salt water. This would not only be conductive, but also just cool enough to preserve the outer ice crust. In the same breath, however, this plausible explanation also raised a new question. What keeps the sea under the ice liquid? Well, fortunately, the solution to this little puzzle was practically obvious. The fact that the water on Europa is in a permanently liquid form is due to the tidal forces of Jupiter. According to this, the moon orbits its planet in a relatively eccentric, highly elliptical orbit. As a result, the gravitational pull of Jupiter also fluctuates in the course of an orbit. The interior of Europa is therefore sometimes more and sometimes less compressed. If the satellite is very close to the gas giant, the ice, water, and silicate rocks on the side facing it are lifted up, and the entire moon is slightly elliptically deformed by the forces acting on it. However, as soon as Europa moves away from Jupiter, it returns to an almost spherical shape. The bottom line is that these constant movements are accompanied by friction in the subsurface, which in turn generates heat. Heat that is sufficient to keep the water under the ice crust liquid. What findings will Europa Clipper bring to light? It is undisputed that the existence of water in a permanently liquid form is a basic prerequisite for the development of Earth-like life. However, it is also undisputed that the mere presence of water is not enough. In order to assess the potential life-friendliness of the Europa Ocean, it is therefore essential to decipher its chemical composition. The problem? Unlike Saturn's moon Enceladus, Jupiter's satellite lacks the geysers that constantly eject water from the subglacial ocean into space and reveal its contents. Thanks to the pioneering use of the James Webb Space Telescope, however, experts are now at least able to catch indirect glimpses of Europa's hidden underwater world. Indeed, the new spectral data, collected using the High-Resolution Near-Infrared Spectrometer NIR-SPEC, confirms that there are increased CO2 deposits on the moon's ice crust. The special thing about this is that the CO2 deposits are concentrated in the so-called Terra Regio, a highly fissured region measuring around 1,800 square kilometers. In essence, the experts assume that the fresh material from the hidden ocean is coming to the surface in the geologically young Terra Regio. In other words, the carbon apparently comes from the subglacial sea, which means that it contains an element essential for the flourishing of living organisms. In combination with water and salt, Europa would therefore already contain 3 ingredients for the recipe of life. A mission like no other. No remote sensing mission, no matter how promising, seems as thrilling as a direct trip to Europa. And in fact, such a mission is already in the starting blocks. NASA's JUICE probe has already set course for Jupiter's moons, Ganymede, Callisto, and Europa. And, if everything goes according to plan, Europa Clipper will leave our blue home planet in October of this year. The main focus of the 6-ton spacecraft is entirely on the potential habitability of the icy moon. The probe will complete 45 flybys of Europa, coming within just 25 kilometers of the celestial body. Equipped with the most modern instruments of our time, Europa Clipper will play a key role in clarifying the question of the satellite's habitability. Over the years, this issue has become a hotly debated point of contention that is subject to constant change and divides experts into 2 camps. Can life even thrive on Europa? Basically, Earth is still the only celestial body on which the existence of life has been confirmed beyond a doubt. With this in mind, the potential worlds of life in space must also be measured against their terrestrial role model. And lo and behold, some inhabitants of Earth have actually succeeded in adapting to conditions that can confidently be described as extreme. Just think of the biotopes around the so-called black smokers, hydrothermal vents at the bottom of the deep sea that do not know sunlight, and yet serve as a home for a number of organisms. The bacteria there are able to capture the heat radiation from the escaping hydrothermal solution and use it as an energy source for photosynthesis. But it can also be bigger. In fact, the black smoker biotopes are also inhabited by eyeless spider crabs, bearded worms, mussels, and starfish. Some biologists assume that we will find such hydrothermal vents under the icy crust of Jupiter's moon Europa. However, the results published a few years ago by NASA scientists in the journal New Science are much less optimistic. According to these findings, accumulations of hydrogen peroxide and sulfuric acid were detected on the surface of the moon, which initially made the celestial body appear far more hostile to life than previously assumed. Basically, the experts assume that the sulfur came from the subglacial ocean, but it is also quite possible that its roots actually lie on Jupiter's volcanic moon Io. The question of the origin of the sodium chloride identified on the surface of Europa is equally unresolved. What is undisputed, however, is the fact that there is, as of yet, no solid evidence of the existence of life on Europa. Looking ahead to the ice and beyond, the upcoming Europa Clipper mission could actually help solve this mystery and pave the way for an even more spectacular mission. In detail, The space probe will also look for suitable landing sites for later research missions. Missions in which an unmanned cryobot probe melts its way through the ice crust and releases a kind of mini-submarine into Europa's ocean. But before that happens, a little patience is still required. Europa Clipper will not reach Jupiter's orbit until April 2030 at the earliest. Your journey to the subscribe button will be a little quicker. Press subscribe now to never miss an exciting video again.